We're going to continue with the idea of this area between two curves. What's going to be different is that we're going to deal with things that aren't functions. A function will pass the VLT. Some of these relations are not going to pass the VLT, which means we can't integrate them with respect to x anymore. We have to integrate them with respect to y. And that's where we switch. This kind of question would be something that would be very reasonable to show up on a quiz or something like that, test for this chapter. I would expect that you know how to graph x plus 1 under a square root. Everybody should know what a square root graph looks like, especially a positive one, and you should know what the plus 1 does to that graph. So that plus 1 is going to move it off the value of 0 backwards, going to move it left to the number 1. So everybody should be able to sketch that without a calculator. Okay, x minus 1. X minus 1 is a linear piece down the y-axis. Okay, so we're going down to -1, and then we're coming up with a slope of 1 like this. It will cross the x-axis at 0. And we would want to know, where do these two things intersect each other? And so you would set up algebraically, when do x plus 1 and x minus 1 intersect each other, and you'd solve that algebraically. Again, I would expect you guys know how to solve this using squares, but I also expect you know how to solve it correctly using squares. You are not going to do a square like this and then 2 squares on the other side. That's not how squares work. You're only allowed 1 square on each side, so you want to use parentheses to square that. I always use parentheses on both my sides. So that'll give me x plus 1. It'll give me the FOILed result, x squared minus 2x plus 1. And then we would set that equal to 0. So we get x squared minus 3x. Which in factored form is x times x minus 3, which means I get 0 and 3 as my solutions. What you got to watch here is that 0 is not an intersection point. Okay, 0 is not an intersection point because we were given the extra instructions that the x-axis is the boundary. Okay, I do not have the bottom half of this absolute value, or this square root. That bottom half is not there. That would fail the VLT. I'm only dealing with the positive half, so it's not that part. So the only intersection spot where they actually cross each other is the number 3. Sorry, that's not perfectly to scale. I didn't draw it super great. But I am looking for this area. Okay, that's the area I'm looking for. So how do I set this up? I want you to think about running a vertical line as a vertical test through here. If I run a vertical line coming down, I'm going to cross through the square root first. But if I keep going with that vertical line, I never cross through. The next thing I cross is the x-axis. So for that section, up until this point right here, that whole section from -1 to +1, I don't use the line at all. That line is not part of my integral. So you might want to even change colors and switch here, because something important happens. On the other side of where I've drawn the blue vertical line, if I do an arrow coming down from the top here, yes, I will cross the square root, but then after that, then the next one I cross is the vertical, or is the oblique line, the linear piece. So that's going to impact how you set up your integrals. So I'm actually going to have 2 integrals here. My first integral will be when the square root is the upper curve and 0, or in other words, the x-axis is the lower curve. That's the boundaries. The edge is the x-axis. The bounds on that are from -1 to +1. Those are the bounds. Then I will add to it a second integral whose has bounds of 1 and 3. That's the green integral. And so in that case, rad x plus 1 is still the first part, but then minus the other, the linear piece. So minus x plus 1 dx. Okay, so setting up that integral, maybe I'll even put boxes. This integral is the one that's representing the yellow section, and this integral is the one that's doing. Zach, I really liked how you used colors on your homework. Like you would shade one color, and then all your work for that one would be in that color, and then you'd switch to a different color. I thought that was a good strategy. Okay.
Don't you want a dx on the first integral?
I do, thank you. Good catch on that one. All right, we're not going to finish this. We're just setting it up. Any questions on that? Okay. Yeah.
Could you just gone from -1 to 3 and then subtracted the triangle?
That could also work. Yeah. Grace is saying she notices that there's a triangle here, so she's wondering if she could. So there's two, she's still thinking about two shapes. All right. Integrating with respect to y. Usually, it's easiest to stick with x terms when you pass the VLT, all right? Stick with x terms when each curve passes the VLT. That'll be the easier way to go. That's what most of your homework is going to be. However, when one or the other curve fails the VLT, so that's our situation. When either of them fail the VLT, you're going to want to switch to y terms. So I'm going to teach you how to do that today. Here's some pictures of graphs that either one or both of them fail the VLT. In the first picture, a vertical line comes down from the top and crosses, and then doesn't, and the next one it crosses is itself. So it's crossing itself twice, so it's failing. In the middle picture, we have a similar thing. The second one, well, both of them actually cross itself twice, and both of them fail in the last one. Like this crosses, and so does that. All right, so these all fail. So we want to switch, and we want to think of everything in the opposite variable. What that allows us to do, I want you to think of it this way. Come at it with a horizontal line. If you come at it from a horizontal line, you're going to hit one graph, one function first, and then you keep going, and the next thing it hits is the other function. It doesn't hit itself twice. It hits the other function twice. Come at it from not left to right like we read, but from right to left, from the positive values to the negative values. Just like a vertical comes from positive to negative, we want to go from positive to negative. So all of these, same thing, if you're going to come across that way. The thing that you hit, the curve you hit first is your F curve. That's going to be the one that comes first in your subtraction. The one that you would hit second would come after the subtraction. That's going to come second. So the formula stays very similar, only it's now the function in terms of y. So you want to use all y variables instead. So the function that's in terms of y, this is what we call the right side function. And the function that's in terms of g is the left side function. So again, if you get those backwards, what do you think is going to result in your answer? Get a negative, okay? Negative answer. The other thing, you got dy on the end. The other thing that changes are your bounds. And your bounds are now the bounds on the y-axis. So if you find the intersection points, it's going to be the values of y. So these bounds will be new as well. We have the lower bound, and we have the upper bound, and those are on our y-axis. So it's right side minus left side instead of upper minus low, and then the bounds are the lower and the upper. So let's just try one of those. So the process is the same. All right, so find the area between x equals negative y squared. All right, well, do we know what that looks like? Well, do you know what y equals negative x squared looks like? Okay. Do you know what y equals negative x squared looks like? We're pretty comfortable with that. What does it look like? Upside down parabola, right? So then x equals negative y squared is going to also be a type of parabola, okay, but facing what direction? Okay, facing what we call backwards or opening to the left. It also fails the VLT, so here's 0, and this comes this way. Okay, that's not perfect, sorry. Okay, fails the VLT, so we know we're going to be in y terms. Then we have negative quantity 2 plus y. You might want to think of that as what would it look like if it was an x. This is going to be a line. So what I would do is I would just do a little quick work on that. X equals negative 2 minus y. So x plus y equals negative 2. So y equals negative x minus 2. Negative x minus 2 is a line on the y-axis. You go down 2, and then you have a negative slope, so it's going to look like that. I'll shade in our region, and our region would be between these two things. All right, we want to identify what the left is and the right so that we can set up our integral correctly. So I always pierce it with a horizontal line approaching from the right. So if I'm approaching from the right and I'm coming across here with a horizontal line, the first one I come in contact with is the parabola. So that's going to be the one that's called my right side. And then if I keep going through, the next one I would pierce would be my, that's not a very good horizontal line. Okay, so then this will be the left. So your integral is going to get set up as the right one, which is negative y squared, minus the left one, which becomes plus 2 plus y dy. And then I need to find bounds. To do your bounds, you'll do it just like you do with algebra with the y's. You're going to set the right and the left equal to each other. So negative y squared equals negative 2 minus y. So those are your two functions. We want to find out when they equal each other. I'll set that equal to 0. So y squared minus y minus 2, which factors in y terms to be y minus 2, y plus 1. That's the factor. Which means that I get the solutions y equals 2 and negative 1. So now I know my bounds. My lower bound would be negative 1. My upper bound will be 2. That's the hardest part, honestly. It's writing the correct integral, and that's where most of the points come from. After that, you just integrate like normal. You do an antiderivative, you plug in, and then you're going to get the value for the area. So we won't go much farther than to just show that we'll have negative y cubed over 3 plus y squared over 2 plus 2y plus c, and we'll be evaluating from bounds negative 1 to 2. So I'm not going to go any farther than that. Just want to show you that setup. Then you'll plug in. Are there questions on the setup for that? Yeah.
And if we were to just continue, would we just continue like we normally?
Yep. Plug 2. I mean, we did this with t's. We did this with w's. We did this with other variables. The variable's irrelevant. It's just the setup. Yeah.
What would happen if like we solved for y?
Uh-huh.
If we solve for y, then
If you solved for y in that one, you would get y equals plus or minus the square root of negative x, which is the same thing. It's the negative square root, so the negative's going backwards, and it's the top half and the bottom half. Okay, let's try another one. Find the area of the region bounded between another parabola and a line. So we again recognize that this is going to be a parabola. And this will be another line. This is y squared minus 1. So Micah brings up an interesting point. If you're having trouble graphing these, then maybe solve for y. Micah, what would you do quick if you were solving that for y, that parabola? Add 1, and then square root. What would you have to remember about the square root? Okay, so I would end up with y equals plus or minus the square root of x plus 1. So that means that this is going to look like a square root graph, which is y parabola, moved to the left 1, and it's both the upper and the lower parts of it. So as we graph that, we'll have, here's 0, it's moved to the left 1, and we'll have the upper half and the lower half, which is why it fails the VLT. And then x plus 1. So x plus 1 oops. Let me get my, okay, up 1 with a slope of 1. So it's a really tiny sliver. It's just this baby little section right in here. All right. Then we set up our integral, and we will need our bounds. As we set up our integral, again, I like to draw something that approaches from the right and see what do I connect with first. I connect with the line first. And so then when I set this up, my line, x plus 1, will come first. And then just to finish, I intersect with the minus the parabola in y terms. Oh, heavens, Mrs. Pfeiffer. What did I do wrong? I forgot to put the line in y terms. What's the line in y terms? X equals y minus 1. All right, good. So let's fix that. I can't. Erase it. All right. Y minus 1, dy. And then we'll find our bounds in the same way. But we can look at kind of what our bounds are. I bet we can get them. If this is 0, 1, and this is negative 1, 0, what are the y bounds? Look at the y values. 0 is the lowest, and 1 is the high. We don't use negative 1 because negative 1 is an x value. We look at the y values only. Those two.